Hey man, down in front. You're in the way. Get out of the way.
So who's in the way? I'm in the way. I can't stand it when I try to collaborate with someone who's just in the way all the time. I'm excited about contributing and I can't because they haven't made a way for me to do that. Now, if you've been watching my channel, you know that I've been killing the last couple of weeks trying to figure out how to allow this sort of thing to happen. I put myself in your shoes and say, what a crap mess. Okay. So hopefully things are getting a little bit better. Let's start by looking at the retro repo here. The organization in GitHub. I added this link right here. Okay. Example file system. I also removed that which has been added to the example file system from the repo up here that normally has the CPM operating system, the BIOS, and all that stuff in it, all right? I may have to adjust some of the wording and things in here, but the short of it is this repo here is basically the same as it's always been, minus the mess that I was creating underneath this file system subdirectory right here. Which is actually still here in this particular example. As you can see, I've still set to main right here. I've been working on this thing called NHACP lately, and I have a branch for all that new work. Once this thing gets stabled and cleaned up and everything, I will merge it into the main branch and have an official release. Okay, so call this a preview of the next release. And actually, this one's probably pretty darn close. So what we're going to get with the next real release of this operating system stuff I'm working on here is a version of the BIOS that will support up to 16 drives on one SD card so that you can, bring in, games and stuff like that without having to kind of merge them all together into one file system. And that's starting to get old for me, and I'm sure it is for everybody else. Some people have been asking for this for a while. Last week, I was talking a little bit about some contributions from a guy named Trevor Jacobs, who has been working with me on trying to figure out some settings and kind of make this our first foray into multiple disks happen. All right. So that will be the first thing that I release. And with it will be the removal of the noise that was in this file system subdirectory. All right. So while I'm not quite ready with NHACP, which is going to allow us to not only have multiple disks, but be able to mount them from the internet, okay, which is even going to be nicer because you don't actually have to then put an SD card in the retro every time you add a file. You can just go get it off the internet, all right? Now, the modulo a lot of restrictions on that statement, but we'll get there soon enough. And there's a couple of different ways and how that will evolve over the course of time. And I'm pretty excited about it. But in order to get there, I'm going to have to make sure that I don't get in my own way, in our own way, okay? So the next phase of this is seen right here, okay? So let's look at this a little bit. In this file system subdirectory, we no longer have the progs subdirectory here. All right, there's still adventure games and the assemblers and stuff, but no other stuff is going to be added in here. I want to keep this thing down to basically just the operating system. And yes, I consider adventure part of the operating system. Okay, for now. Okay, so that means that we take the CPM and the BIOS and the utilities that come with CPM that we linked in from over there. All right. And that's it. And this will build what we consider, drive A. And in that drive A, as per CPM standards, it will put a copy of the operating system on the boot tracks. Okay? Now, let's look at that really quick while we're in that neighborhood before we look at what happened to the other stuff. All right? So if we say git tag -N6, oops, if I spell it correctly. Hopefully I didn't just add a tag. Yes, I did. Blast it all. Well, I won't push that. I'll remove it. This is the tag of question right here, okay? So what we've got, that's today's dates. Remove the test programs from littering up the file system. And that's exactly how I feel about it. Don't put stuff where it doesn't belong. You already know there's a hello directory and some test programs and stuff in here that go along with the retro hardware board. And maybe in the future I'll factor those out as well. But those are actually not part of, running in CPM and stuff. These are really, rudimentary system test example programs. All right. For now, I'm going to leave them where they're at. What we have is the file system directory here minus the program subdirectory. All right. And we've got this make default, make local, blah, blah, blah. All right. So this is a little bit new. Let's look and see what we've got in here. I think I've updated these comments basically by removing the ones that are no longer relevant. You see stuff in here that you don't think belongs here, let me know. And pull requests are welcome. And they'll be much easier now because every time I touch something, I don't have to release the whole operating system repo again, right? So I'll be working off to the side in a different repo with new application programs and stuff. Now, we'll also work on the operating system, but only when we mess with the actual operating system will we be messing with this repo. So this will become increasingly stable over the course of time. Well, the dynamic activity is elsewhere, and that's the goal. All right, so what do we got going on here? Not a lot has changed in this makefile other than removing things, okay? The few additions are these two include lines that allow us to configure the build. And when we configure it for our own local work environment, like on my desktop, I prefer to use things a little bit differently than when I'm on my Raspberry Pi. As you know, the official default build environment for the Retro project still remains on a Raspberry Pi. So the default settings we'll see in this file here are identical to how I always have worked in the past with a Raspberry Pi. You can create an optional file called make local, and I'll show you this and how it works in a minute, that allows you to override the default values that are based on the Raspberry Pi environment. And to do so without having to edit this makefile, all right? Or change the defaults, okay? Whenever you add something or alter it or configure it by simply creating an optional file, you're doing so without then creating things that you have to then later on ask yourself, oh, should I commit this? Is this supposed to be part of a pull request? No. Any of your local junk should stay in here. And if you have to edit anything in addition to that, then I've either made a mistake you need to repair it, or you're actually creating new material and stuff that belongs to be committed in here and so on. But if you're just a passerby, you want to build this thing, or maybe you play around with it for yourself or something, and you don't want to get knee deep in, editing tons of files that I've made a mess, which happens all the time, as you probably know, when you download anything off the internet. At least half the time, it's done in a way that makes it very difficult to configure and figure out what's going on for your own environment, okay? Hopefully, I've got that reduced to only a couple of things that happen in this make local file that we'll look at in a minute. Okay, so after that, these configuration variables are all we're going to get out of this. We fall into the same stuff that we've seen before, minus the noise related to all the program subdirectories. So when you type make, by default, it's the first target it sees in the file, which is actually up here, all. And that becomes the default thing that it will do. I could put ABC in there, and then ABC would be the default, okay? The reason you put this up here like this is that if somebody has any actual targets and rules or recipes in here, that they don't end up changing the default build rule. So no matter what, your default will be called all. And my all rule officially is down here, okay? That's why it's there twice. I talked, I think, about the phony stuff in the past. These are all target names that are not real files, so that it doesn't confuse make into thinking it's supposed to create a file called Word or a file called all and so on. These are merely used as triggers to get make to start doing something that you wanted to do directly without using the default rule. Like burn myself an SD image and stuff like that, okay? And the usual clean all and make clean, delete all the target files that, that have been generated so we can erase what we've created, clean up our mess. I always create a world rule that does a make clean followed by a make all, because in order to keep the make files super simple to understand, they don't always have 100% perfect and proper dependencies, i.e. this one right here. If you know what dependencies are, you recognize that this is kind of stupid. And by that, I mean, if this file does not exist, this makefile cannot initiate the activities required to create it. And that's what dependencies are all about. So I'm a little lax on that. And the result is the makefiles are much simpler, but you can get into trouble if you don't rebuild things forcibly on your own. Okay? I admit I'm lazy. That's what Make World does for me. It just cleans everything out and rebuilds everything. So I don't have to worry about whether or not, did I forget to compile something that was updated because some, transitive dependency may have altered or something like that. So you'll probably see me or have seen me over the years on my channel type Make World all the time. And that's why. That's what it buys me. Simplicity of the makefile in exchange for, I need to be careful, a little more careful on my own. Okay? So Make World forcibly recompiles everything. How do we create a disk image? I think I've talked about this numerous times in the past. I have done some factoring here. This disk def variable, it's a make variable when you see a dollar and an open parenthesis like that. Not a curly, that's a parenthesis. This is a makefile environment variable. And those come from these files up here. And the disk def name, I'm moving forward on the disk defs. We're changing the format of the file system a little bit. And the reason we need to do that is because there's not enough memory to hold, if you want, 16 file systems, which seems ludicrously huge, which is the default build right now. If you want that many file systems, you're going to run out of memory. So I'm changing the way the file system works in order for this to happen. Now, CPM can deal with that, but everybody has to be in sync. So this is configurable up here in these variables, what kind of file system we're creating. That's all. I'll have to record a video and walk through the morass of details and why all this is relevant sometime down the road. I've touched on it in the past when we created the file system in the first place. That all still holds true, and that's probably 90% of what needs to be reviewed at the time comes. And we also then have to augment that with some of the discussion of the decisions that were made and why they were made to actually change the way this thing is created. Bottom line, right now, this is configurable from these files up here. So otherwise, we still create it the same way. We use the makefis and the CPM-CP to go out and take all the files that belong in our file system and we put them in there. This is the same as it was before. I don't know if I made these modifications since the last time you might have seen this. $@ means put here whatever is over here in this recipe that a lot of people call this a recipe. I call them rules, but a lot of people call these recipes. So $@ is whatever the target name is for this particular recipe. There's other variables as well, like $caret and $sign. We'll see those. I'll talk about them when we encounter them down the road. So this is otherwise not changed. This is go take the disk def definition from the environment up here and create a bootable disk with the operating system from here. We've seen this for the last 18 months. And this over here is, again, the target name. So this whole thing is self-configuring based on the name of this target. So if I change it to xyz.img, and this will make a file system in a file called xyzimg, if that was the case. And when that's all done, we copy into that file system from all these guys over here. So that leaves us with the differences being that I have removed basically the extra lines in here that went out and grabbed all the executable, the COM files out of the program's subdirectory tree, okay? Keep it nice and simple here. Same as before. I changed this rule a little bit to kind of make it easier to read. That when you type make burn, it says I need to have a drive image, so it creates this transitive dependency up here. And if it doesn't exist, it goes up here and creates it. That's just make. That's how that works. That's why it works. It was supposed to be. If you haven't figured that out yet. All right. So if I want to burn my SD card, it's going to execute this thing here. Let's look at this one because it's new, and I rewrote it since last time. On its own like this says don't bother to print all this crud out. This is one single giant command with all the backslashes for line continuation kind of thing. So this says if the host name on the machine that's executing the makefile is not equal to something that comes out of these config files up here, all right? I used to have Raspberry Pi hard-coded in there, for example. Now there's a variable. Okay, so if I'm not on that machine, or some other thing is not true, then print this message that says you're either not logged into the machine you're supposed to be on, or there is no, what we'll see, the device that holds the block device that we're going to copy into down here doesn't exist. In other words, I'm checking the configuration so that I don't accidentally type this in on the wrong machine and cause myself a problem. So the host name check is pretty reasonable. Also, you need to make sure that the darn drive is mounted. Otherwise, those of you following along at home might have noticed that if you do this once in a while and before you put in your SD card, you forgot to do it, this DD will still work. And then instead of writing it into the SD card, it'll create a new file and create a mess for yourself in the dev directory where you really don't want to do this. I mean, this is a terrible thing. So basically, I added from what was there before, not just checking the host that I'm on, but make sure the darn SD card's plugged in. I did this repeatedly. It drives me nuts. This is because I'm incompetent. I had to add this rule here. My life is much better now. So all in, if I'm not on the host I'm supposed to be on, or I don't have the disk mounted that's supposed to be mounted, then print out a complaint message, and this will cause make to stop running. It's false. It's an error. This is an easy way to stop make from going. If it continues to go because this was not true, it'll fall down and do what it's always done, and it'll say copy something from somewhere. This thing represents sort of like the $@ up here represents the name of the target. This thing here represents the name of the dependency over there. This, of course, won't work if you put more than one word on here, but I'll leave that for the experts, okay? So what this will do is it will say, go get the file that's represented by the dependency in this recipe and copy it into the SD block device that we'll see is defined in the makefile defaults and the makefile local if you want to change it. But otherwise, it does the same thing it's always done, all right? So this is a better, more safer way to do that and less lines of code. And I think it's just more clean. All right. I added another rule down here called blank all SD. This is incredibly dangerous to do. So you really don't want to do this by mistake. Now, what this thing does is it will just basically erase all 16 slots, as we like to call them. All the drives that are on your SD card will be erased. So I find this handy for testing purposes. Because I don't want to have to go in there and clear out 16 images. So I have one rule to do them all. So let's look and see how this thing works. Does the same check we had up here. Gripes in the same way if I don't have the disk mounted correctly. Then it does this, which took a little thinking and some Googling and whatnot. What this thing does is it reads a file from dev0. And now I could just put dev0 onto my SD card and call it a day. I could just say dd, output file is this, input file is dev0, and write 16 times 8 megabytes of blocks onto the SD card and call it a day. And it would zero out the card. That'd be fine. But, as I mentioned before, CPM prefers that all the bytes on a blank floppy disk be set to E5 in hex. So what we can do is what we need to do is generate a lot of binary E5s. So what's the easiest way to do that? I can write a program to do it, or I can say, look, I have an infinite supply of zeros. Run a program, which basically means translate. Read from dev0, and then translate every 0 to a 3, 4, 5. Now, unfortunately, this dum-dum doesn't support hexadecimal mode. So it's octal. So an octal 345 is a hex E5. All right, so this thing is going to read 1 byte at a time, translating each 0 to a hex E5, and then write them 1 byte at a time into the DD command. And I did not specify IF on the DD command, therefore it will read from standard in, which comes from the pipe, which is this thingy over here. Now, C-type equals C, what's that all about? Well, thank you very much for all the internationalization of alphabets and everything else that went into, Unix-like operating systems and other operating systems since the 80s has created a morass of difficulty. It really is. If you have your, the locale, all right, which is what this thing represents, where you are in the world and what language should you be using. If you set it to C, you're just telling it to shut up and act like it's 1982. And party like it's 1982. 1 byte per character, none of the Unicode, none of the foreign stuff. Otherwise, this thing will get confused, okay? Make it like it was 40 years ago. 1 byte at a time in, 1 byte at a time out. Don't get cute. Don't help me. Generate a bunch of E5s, send them to this command over here. That's it, okay? And it writes out 16 times 8 megs each into the SD card, which is exactly what you want to create 16 drives of all blank. This is the end of the makefile. I got an ls rule because I got sick and tired of typing. This is the same rule that was in there before, but I think I called it like lscpm or cpmls or something like that. I got sick and tired of typing out all that, and I shortened it. That's all. I'm generating a file called drive.image. Before I might have called it something else. It's been changing a lot lately, but this seemed like a reasonable simplification for the file that represents our operating system, our entire disk image that this thing generates. This thing does an ls command. I talked about that before. It has to know how the format of the file system works in order to print it out. And this thing represents the name of all of the inputs of the dependencies. All right. So if if there was a whole bunch on here, it would just list all of them. Okay. And by list, I mean list the files that are inside this file system image. Okay. So you'll notice I just removed a bunch of stuff and I parameterized that which remains. Parameters come from here. Okay. The way this works is if you say include and you give it a file, that means to go out and get that file. Just like an include does in a C program or an assembler and stuff like that, okay? Go out and read this file and incorporate it into the one you're processing. So I've got 2 of those. The second one has a minus sign in front of it, as you can see right there. That means that if there is no file called make local, then don't do anything, shut up, don't warn me, don't help me, just forget about it, okay? So read this in and complain if it does not exist. Read this one and shut up if it does not exist. Okay? So, and just move on. So this will build out of the box with the defaults and do the right thing if you're on a Raspberry Pi that is configured the way I talked about before. Let's see if you can type better than I can. I really can't type and talk at the same time. I guess not. So what is in the make default file? Okay? Or what do we got here? As I say, these are the default values of various things that could be of interest to more than one makefile. Here's where the disk dev value is defined. In the old days, we had a Z80 Retro. I think it was 2K was in here. Now there's an 8K. And we'll look at that in a minute. This is the file system. The only real difference between yesterday and today is that the 8K represents the size of the allocation blocks that are in the file system. And by raising that value, I think I mentioned this last week, By raising that value, we reduce the number of ALV entries inside the operating system. And if you recall, an ALV entry is a single bit, and there's a big array of them, one for each disk. So if you have a whole bunch of disks and you got a lot of ALV bits, it causes too much memory to be consumed, like over 8K out of your 64K. I mean, that's an enormous amount, and it turns into a problem. So by increasing the size of the allocation vector from 2K to 8K, we use less memory inside the operating system to keep track of things. Of course, there's pros and cons. That's a subject for another day. Point is, this represents the format of the file system. That key right there matches what comes out of this file here. If you've forgotten, inside here, this is the one that we've been using for the last year. Here's one that will create one with 8K blocks instead of 2K. The real difference is this block size right there changed to that. Okay? No other changes have been made. I was considering trying a 16K size, but for some reason the CPM copy command likes to core dump on this one. So there's probably a bug in there. And it can't possibly be that anything that you do here should never, ever cause a program to dump core. That's just stupid. Now, granted, I may have set something wrong here, or there's other issues at hand, but when you write a utility, don't dump core because somebody's an idiot. Print a message that says, you're an idiot. Because you know who looks like an idiot when your program dumps core? You do. So this doesn't work, and I don't know why. And I hope that whether I'm an idiot or not, I can guarantee you that the utility is broken and doesn't properly support that block size right there. If you know better, let me know. Please. Pull requests always welcome. All right. So let's get back to our make default settings here. Okay. So here's the disk def value that says here's the kind of file system I want you to create. That's where I want you to put the data when you do the burn. And here's the host name that you better be on when you do the burn. Okay? So that's the make default. And the way the Git stuff is set up, there's a git ignore file in here that says ignore all the things that start with make.local. That means this here and this here. If I type git status, it doesn't say anything about these two files, even though for example, this is not in the Git repo, right? There's nothing to say about it. It's not even there. It is completely ignored by Git, okay? And the reason you need it to be ignored by Git is that if you do something like git add dot, and then you say git commit, it will not add these files because they are opaque and being ignored by Git. If you don't tend to this correctly, you create a repo, and then other people try to collaborate on it, and they're trying to add files and commit. They're constantly committing crap that doesn't belong in the repo. Okay? Don't put this crap in a repo. So tell Git to ignore it and use them as they're intended as local overrides to the defaults, right? So here's my make local. My make local, I change the device and I say, hey, I make sure I'm running on this host. Simple. And if I git clone the same repo over on my Raspberry Pi, on my Pi, I don't have this file. Or if I do, I certainly don't tell it to generate an error if I'm running on, some other host. Okay. So that's what the point of this is. You can create this local file, override the defaults, and never create any modifications that you have to remember not to commit back into repos and stuff like that. This is the whole reason we have git ignore, and the whole reason that I set this up to have these optional files that we can use to override the ones that are in the defaults. All right, it's annoying because where is the thing coming from? I'm there. I've been there. I get it. But if we don't do this, then what happens is people are constantly changing the defaults for everybody else, and then nothing ever works. Oh, I upgraded and now nothing works anymore. I don't want to deal with that. I don't have time for that crap. Neither do you. So let's not get into it, okay? So this is the entire change that's been made in this particular round. If I type make world, still compiles everything everywhere. If I go into the file system where we just were, and I say, oops, if I can spell, and I type make burn. Now note, I specifically do not have my SD card plugged into my system right now. And it comes back and says, you're either not on the right box or you're a dingus and this thing is not mounted, okay? So that's what it'll do. Now I plugged in my SD card. You hear the ding, I think that might have taken and been recorded. I do this, and now because it's doing a sudo command, I got to type in my password. And there's my my disk image on the SD card. Now, this, as you can see, what the command did right there, it took the drive image that we just compiled up here, which we've done that before, going over that a million times, copies it out onto my disk, which is on SDC1, which is different than on a Raspberry Pi when it is SDA1. Okay, so that's how I overrode that without modifying the files that are in the repo so that I have to constantly go out and redo it every time I want to pull an update or push something back. Okay? Same thing for the file or the host name that is in my local as well, right? So I got to be on the right host for this particular build environment. I got to use the right device name and so on. Okay, so what else is going on? Well, we can also, if I want to, this particular drive is new-ish, so I can run this as well. And we can do a full blanking of the thing if we want to. This takes a little while on my system here. What we got there? 5.5 seconds or something like that to write out 22 megabytes per second. Okay. All right. So what I have now is a completely blank disk. So now I got to do another make burn. Okay. Now I have basically a very virgin disk. And it has a single slot drive A filled in with data. And this is basically what we've been doing for the last year and a half. All right. But it's been configured in a way to make it much more friendlier to other collaborators to customize, localize their settings so that they're not constantly having to be fumbling around. Okay. Now, real quick over here before we warp into what happened to the other file system files. What happened over here, right? Last time I talked about the way I created the call gate, and there's the no cache and the DM cache and the stub, and I had these like macros and stuff that I set in there, so each one of us can configure our system however we want it. But in the end, this call gate file started getting a lot of stuff in it up here in the top, and how it would configure and do some debugging and do the select disk operations and all that. Didn't touch any of that up there. Down here were all the configurations for the disks. Well, once again, we're configuring for each local, configuration. A couple of lines in a file that is otherwise relatively large and shouldn't be touched. Leave this file alone. I give you a really crappy example. Do as I say, don't do as I do. Bad advice. Okay, sorry. So, in the bottom of this file, I do this include diskconfig.asm. All right, so get out of here. Get out of the way. Okay? In diskconfig, this file is where you saw the rest of the stuff that was on the bottom of the call gate file. All right? In here, we can include whatever drivers we want. We can use whatever macros that the includes here provide to configure, whatever the DPHs and the DPBs for each one of the types of file systems that the drivers support. Now, in this example that I'm pushing out, I'm going to create 16 logical drives. The BIOS knows how to access drives A through P. And when it tries to get the data off the SD card, this is where it's going to look. We've been familiar with this one up here. Talk about last week. Talk about this on and off again over a year. First partition on the SD card, if you configure it the way that I recommended from the get-go, puts your first partition starting at hex 800. That's why there was an 800 hard-coded in the driver for the SD card long ago. That's why drive A is sitting at hex 800. Drive B is this plus 8 megabytes in hex, expressed in chunks of 512 byte blocks. Been over all that before. So what happens is each one of these disk images all sit in one partition on the SD card. That partition starts where it always has at hex 800. Each subsequent disk image, logical drive or slot number, I should probably update this doc to be more consistent. A lot of the other doc refers to each one of these as a slot. Okay? I don't want to refer to them as a drive, and that'll become apparent later on when we start talking about network-mounted drives and stuff like that. Because what does that mean? There isn't one on the SD anymore. What slot's going to be used? All right? Don't want to get you confused with that right now. Right now, we've got 16 slots or logical drives on the SD card, and these are the SD card physical block number, the absolute address of where they all start. Okay, DP0 through 15. These other ones are commented out that I use for testing. You can go look at the stub driver if you want. There's the regular cache. You can only use this one on drive 0 if you want. It'll work on drive A, but you really want to use it here and nowhere else if you do that. Last time I had 4 of them in here. Now I got 16. I couldn't do 16 last time because we used a different disk format that had larger block sizes, which required bigger ALVs. That's why they didn't all fit. Now they do. Okay? And it's not this file that changed. It's the driver, the no cache driver that changed. So let's look and see what's in there. Nothing in the file until you get to the bottom. And down here, there's 2 sets of configs. You see this if 1. All right? What happens is this one is set here to be 8K allocation block size. Okay? This is the one I'm using right now. Here's the macro. We talked about the macros last time. It creates the header. The header has a pointer to the DPB. Right? It also has these fields to hold the absolute address over the disk starts. It used to be hard-coded. Is now configured in here. Talked about that last time. And then we create this ALV based on the size of the disk image that has been configured up here. And this is hard-coded. Annoying, still hard-coded. This driver, as it's configured right now, must not require a bigger ALV than this. It must use this exact set of disk parameters. And by that I mean, here's how many blocks there are, and their size is based on this whole thing here. And we've talked about this in the past. These 3 things combined tell the operating system how big each allocation block is. This one over here says how many there are total. It represents, it's not literally that number, but it represents the total number of allocation blocks on the disk. Here's how many entries there are in the directory, -1. These we talked about last time as well. This says that there's 2 allocation blocks to hold the directory information. When you have 8K in each allocation block, you only need 2. When you had 2K, we needed more, right? We needed 8 of them. So these adjusted a little bit. If you scroll down here, this is the setting for 16K. It doesn't work right, so it's commented out. It's also, that's a very big block size. If you use a huge block size, notice the ALVs are getting smaller. We're wasting less memory, but we're wasting more disk space when that happens. And the reason that happens is that if I create a file that has a hello in it in text, the smallest allocation block I can give it is 16K. I have 16K plus 1 byte in a file. I need to allocate 2 blocks, which is then going to be 32K total just to that file. So it creates a lot of fragmented empty space on the disk and wastes that space. So if you have a lot of small files, you want to have smaller block size. If you have a few big files, you want to have fewer big sizes. This all has to do with efficiency and the amount of memory that gets wasted on these ALVs, okay? We can talk a lot more about that in the future. For now, I've settled on 8K. Main motive is to reduce the size of the allocation vector, okay? Without wasting too much disk space. I think 8K or 4K might be a reasonable size. At 8K, we have just enough memory in the BIOS area without wasting more space than we already do to hold all 16 drives if we want to, which, if you think about it, it's kind of a ludicrous amount of disk drives to have in there. We might not want 16 of them, and you're free to do that. If you want to change it, change this config file, okay? So that's how you configure this thing. You can have up to 16 of them. That limit is imposed by CPM. And you just remove them out of here if you don't want them all. They don't have to be in order. You can put any slot anywhere in the order of things. I would recommend strongly that you do it orderly instead of disorderly, because you can really get yourself confused otherwise. All right? So this is, I would argue, a minor upgrade since the last time we talked, and it is a little bit more configurable. This is still not set up to have like localized, customized configs. It is a file that's in the CPM, or rather in the Git repo. So if I were to modify it, then everybody would get it. All right. So we'll probably have to all agree on what we want these settings to be, or we'll have to rig another way out with like make local. There might be a config local or something like that, so that we can set it up for ourselves without infesting the code and confusing everybody else. But honestly, if we were to do that and localize it for everybody, then we would end up with a situation where everything is incompatible with everybody else, and that might be a whole set of confusions in its own right, which means we have to go a whole nother round of creativity and do something that CPM has never done, that I know of, and store the actual DPBs in the file system itself. So, for example, in the bottom of this file, rather than hard coding them in here, what we could do is go out to the disk. This is what you need to get. The stuff up here is not as important. This is not something you have to worry about on a per configuration basis. It's the stuff down here, and the size of the ALV, of course. But if we were to store this on the disk in a very well-known hard-coded place like the first sector, and call that part of the reserved space, right, in the parameter block, which is in the other file, the file system directory over here, right? If we use one of the some of the bytes in this reserved area, these 32 reserved tracks, to hold the disk parameter block, and we wrote the appropriate code for the driver to read it and to store it in its own memory, and then analyze it and decide whether or not it has enough memory to hold the ALV, et cetera, et cetera, et cetera. It'll take a little bit of time to make sure we do it right and not screw it up. But we could actually do that. And then the thing could be self-configuring, and then every disk image would be compatible with all the other ones, as long as they store the DPB in the disk, which means, it'll have to be the retro community, because CPM is doing us no favor in that regard, okay? Think about it, right? We'll get there eventually, but they're not doing us any favors and letting us recognize whether we have the right kind of disk format or not, and it really is annoying. Even back in the day, I mean, it's something you got to live with, okay? So I apologize, not my decision, but we'll have to work our way out of that. Okay, so that's what's going on here. And as you can see in the Git status, I'm on the JRW NHACP branch in the repo. I showed that before, right? So make sure that you've chosen the right one if you want to see the code for today. Or you could probably go over here and find a tag. Today's tag is right there. And you can click on that and you can see the files in there, okay? I think was it I don't want to release a release from this thing. There's a way to say show me the code or whatever. I think you click on one of these. Then it'll go in and around and come back with the code, show you what's changed and all that fun stuff. I think I talked about this before, but this is all part of what GitHub provides you, the ability to view all these different branches and stuff of these repos. Okay, so that's what's going on here. Now, where did all this stuff go? Well, it went over to here, the example file system. Now, it took me a few hours to decide how I wanted to make this work. Again, we've got the makefile, we've got these defaults, and I can put a local in there and override the defaults. And I'll do this in the exact same way with the exact same variables that we used for the CPM repo, the BIOS repo, okay? In other words, I define how and where the SD card driver is and which host I'm on and stuff like that so that I don't accidentally write something to the wrong drive. And with the defaults, as you can see here, set to same as the OS. You have this has to match or it will not work. We'll talk about that in a minute. This is the same as the other one. The default host name is Raspberry Pi. On my local, I change it to my desktop. And this down here is going to be a variable that says which one of the 16 slots do I want to burn my file system image into. Obviously, you don't want to burn it onto slot 0 because that's where the operating system just went. Okay? So remember what you're doing here. And every one of us might want it a little bit differently. So don't hack up everything in someone else's repo. I mean, the idea with this is if you really don't know how to go about this and you don't want to create one and start it yourself, you can run with this. I tried to get it as simple as I could stand and still make it, be able to create, multiple files, multiple programs. Here's the teletype, the video, the VDP stuff, some example programs, even a basic program in there. And I've been tinkering around with some programs down in here called NHACP, which is a new and coming up protocol thing that allows us to do something that I hope we can use to mount disks over the internet kind of stuff that I was just talking about. All right. Now, this basically is everything from the file system directory down from the other repo, the CPM repo. I just moved it over here. And then I cleaned out some cobwebs. All right. So this is basically what you used to see with the other one. Factor it out. If you want to fork this thing, create your own file system, put your own files in there. Now you can do this independent of the OS repo. All right. And that's the whole goal. You want to create some games or something, you can use this as an example or trash it. I don't care. But no matter what, you need to be able to accomplish essentially what this makefile does to create a new disk image. And then you can copy it onto one of the slots in your SD card. And then when you're running inside CPM, you'll see all of a sudden drive whatever, B or C or D or J, K, wherever you want to put it. And your files will appear in there. So you can manage all your own stuff independent of everybody else. Maybe somebody else is posting some games. Fine, go out and grab their image file and pray that they use the same disk defs, right? And then stick it on whatever slot you want it. Okay, so that's the goal here. We can, anybody that wants to create a file system that has, anything of value to the community at large, let me know. I would love to fork a copy of it and put it in here. I do not want to be the upstream owner of all the file systems. That's not my goal. I want to be the downstream guy. You can create file systems. You can create any program you want. Let me know. I will fork it and put it in here. And then when you do updates and stuff like that, I can pull them down in here. Or I can simply list a link to your repos from up in here. And that way we'll have a nice place where we can just find everything that's going on, right? And more than welcome to participate in all this stuff. I can't wait. I really can't. I want everybody to be writing games and fun stuff so I can play them too. I don't want to have to do it all by myself. That would take forever. Okay, so how do you use this thing? You go in here as usual and you clone it just like you did with everything else. And what I do, the default settings are set up for this. Here's my repo. I just CD'd up one. There's my repo with the BIOS and stuff like that in there. I got all this other junk I'm playing around with. Here, I should rename this. I renamed this. So this is a really bad example. I should have renamed this directory. But if I say get remote -v, you can see this came from the example file system repo. I originally just called it file system, bad name. This directory is a bad name, but the repo is okay, all right? So sorry about that. Let's see what we got going on in here. So this is what you were just looking at in there, plus this local file. It should come as no shock to you that this is what we just saw on the repo and the make local right here. Let me skip some lines so we don't have a hard time separating one from another one. Local rules for my own build and burn. So what did I do? I said, I want to use this, and I'm on that host, just like I did for the CPM repo. All right, now I'm in the overriding just those two. The defaults are fine. One of the defaults that's pretty important is where the heck is the CPM image? Now, this will not be necessary for everybody. I put this in here because it may or may not be of use depending on the kind of program you're writing. It turns out, if I ever get this done, I'll start talking about how the NHACP stuff works and how I'm testing it. How do you write a program for this thing? We really haven't talked about that a whole lot. What does it take? How do you debug it? How do you get out of your own way? All right. And that is one of the things I'm doing right now with NHACP. And maybe I'll do a little bit on how you can write a regular old COM file and load it into a file system like I am in here, and then run command line programs to exercise subroutines that you want to debug. And we can move away from DDT and the 8080 similar mnemonics and onto something called ZSID, which I've been experimenting around with. I can show you how that works. And that's basically the exact same thing as DDT. If you want to try it, just run it. You'll recognize it is all basically the same commands and stuff, but all the instructions are in Z80 instead of 8085. I probably should have started with that one out of the gate, but it turns out ZSID has some minor differences that can be not intuitive because it was designed to do more than DDT. So the more can get confusing until you understand what more it's supposed to do and how to avoid it if you don't want it. Okay? We'll get there. Anyhow, this is what I'm using in my NHACP program. My NHACP, when I compile it, it needs to know where the operating system is. And relative to this repo here, right, I'm in this example file system repo, poorly named directory. And if you go up one directory, you see that's where the CPM directory is over there. All right, with the repo, the top of the repo. So what this is, you will see in a minute, top represents the top of the repo I'm in right now, which is the file system repo. I go up one directory and then back down next to my file system repo, my example file system repo, I should say. By default, if you just simply check them out, one right next to another, this rule will be correct. If you want to do this or put them somewhere else, you just have to create your own local, your make local override and tell it it's not there, it's somewhere else. That's the whole point, right? You don't want to use 8K, create a local one, put a different one in there. Same thing for the host name and the derived name. And down here, as I said, this is the slot number that we want to program when I type make burn from inside this repo. Okay. So let's look at the make file in here. Now, I did my best to pare this down without having to throw up in my mouth. This up here is kind of complicated and subtle, but you'll want this, okay? The reason you want it is because this becomes self-configuring. You can hard code all this stuff if you think that's easier, and I would argue it actually is easier to create a shell script to assemble your files. It doesn't matter. Just get it done. This is one way to do it. It happens to be one way that I like because it's self-configuring. And by that I mean I can add more programs into the tree of files here. And I don't have to then go up to my makefile and add a bunch of rules for all the new programs and make sure that that gets all typed in every time. I personally hate that. I'd rather spend an hour figuring out how to get these 3 lines of code to work right and never touch it again. Okay? And that's exactly what I did. So let's let me just say that this line of code right there sets this src variable, you can almost read this, to this wildcard match. I want to set src, which to me means all the source files, or all the ASM files that are in the directory tree underneath the progs subdirectory. So this is going to be the name of every single file that ends in .asm. This thing here, I'll let you go read the manual. What this does, you can sort of see what's happening in there. Even if you can't write it, you might be able to read it. It says the programs, which to me are the com files. I probably should have named this thing like comprogs or something. Maybe in the future I'll rename this to be more like ASM source and com program and whatever. Might have needed better names, but what this is doing is it's saying go to take all of the files listed in this source variable up here, okay, and then convert all the ASM part, the suffix, the 3 characters, the file name suffix, ASM, change it to com. So if you look at these 2 variables, when the makefile runs, it'll say source equals, and then a ton of files that end in ASM. In fact, if you just take that like so, and you type in ls, and you paste it in like this, that's what that variable equals. Here's all the ASM files underneath the progs in this whole tree. Now that's structured in such a way that underneath progs is a subdirectory. You have to be very consistent in order to use a simple rule, okay? Underneath progs is a directory for each program or each set of programs, and we've seen these before. This one's new, but we've seen the VDP stuff, the teletype, and some example programs over here. I even have some basic programs over there, all right? Point is, this is the name of all the assembly source files, okay? And then what this does is it says, I want you to convert all those names to com. So and basically it would be an expression like this that ends in com. But you'll notice there aren't any com files, okay? That's why I didn't just say wildcardprog**.com. What I did say is take all the ASM source file names and convert them to com file names, even though at this point in time, those files may not exist. I'm going to use this to define the target names of all the files that the makefile has to create. That's the whole point of this, okay? I then have to know what are all the directories that all these programs are in, as we'll see later on. It's very inconvenient not to know where they are, okay? And that's what's happening here. It says go to each one of the items in the progs list and extract just the directory names of each one of those. So this one will be all the ASM files. This will be all the would-be com files after the assembly is all done of every one of them. And this will be the list of all the directories within which all these files are located, all right? So that's what's going on in there. If you want to know how to write these yourself, go read the makefile manual, all right? And as I mentioned before, the first rule is a default rule, and this thing says I want to create a thing called disk.image. We saw this before. We'll talk about it a little bit later. each one of the make files that appear in here if you are going to use these files. The convention I use all the time is I say this is the top of my repo relative to the current makefile. Otherwise, it has no way to know. Okay? Programmatically, you could probably figure it out using Git or something like that. But you need the make itself needs to know where the root top level is for the repo. And at this point, it's in dot, the current directory. If you go into these subdirectories down here under progs and stuff like that, and there's a makefile down there that you don't have to use these, but if you do, you'll need to set top equal to like dot dot slash dot dot, because down here, it needs to know that you're 2 away. Okay? So that's why we set this even at the top level. We include then top slash make and the make default and the make local. Now, I don't have to put top in here in this particular case because we know what's in the current directory, but for consistency's sake, I'm going ahead and left that in here. So if you copy this make file into the subordinate directories, then at least you have an example in here that has it in there already for you to go. This is exactly the same thing that was going on in the operating system build. The only difference is this. Remember you saw the disk slot in the make default? This is where we use it. Make default wants to go into slot number 1. You want to burn slot number 8? Then fine. Go in your make local file and set disk slot equal to 8. Override the default. That way you don't have to commit it back to the main repo, etc., etc., confusing everybody else. All right. What drive do I want to program it into? You saw that in the default in the local before as well. Okay. Check to make sure I'm in the right place. Input. Take the disk image file. Output. Write it into whatever the config says device to, whatever the target device is. Put it in here times 16K. All right. There are 16K times 512 bytes in each disk image. That's your 8 meg. So, disk slot, if you were in a burn drive A, it would be 0. This doesn't even exist over in the operating system area because the seek distance is 0. I don't even have to specify it. But if you want to write it into slot 1, 2, 3, 4, and so on, it'll be 1 times 8 meg, 2 times 8 meg, and so on. Now, we added this. Trevor pointed this out the other day. I'm like, why didn't I bother doing this myself? I'm a fool. I should have put it in there on day 1. After you do a DD, quite often you'll see me type sync on the command line to make sure that the data is flushed out to the SD card. This says do it automatically when DD runs, so I don't have to even think about it. All right? Improve your reliability. Okay, but otherwise, same thing as you saw on the OS. This is the LS, same as the OS. Disk image, same as the OS, but we're using more fancy automatic variables. Disk image is dependent upon all the programs. This is why we need this fanciness up here. What are the names of the programs? Well, if you got an ASM file, this is naive, I agree, but it assumes that for every ASM file, you're going to create a COM file. Which means if you have a bunch of ASM files that are really kind of only exist to be included in some other file, you might want to name it something unlike the examples that I have been giving out for a year, where I name them with .asm suffix is my point. If you end it with a different suffix, like ASMH or .inc, INC, or something like that, then it won't trick this rule up here. It won't make it think that it's supposed to create a COM file out of it and confuse this part of the build. Okay? We can talk about that as if necessary as the time comes. Yeah, I think you can figure that out. So what's the point here? As long as all those COM files exist, it can build this image. If they don't exist, we'll look down here and see how it will create them and how it forces the sub directory makes to take place to create those. Once they've all been created, this removes the current disk image you saw in the operating system. It creates a new one. This one is blank. Go get the disk def, just like we see in the OS. We use the $8 at to say there's the name of the file it wants to create. We do not have a -B over here because this disk does not have an operating system on it. And you might argue, why don't we use a different disk dev to get rid of the offset 32 tracks? I want to use the extra space, blah, 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 blah. Well, why don't you go first figure out how to make sure that the operating system's configured to understand what happens when you have a whole bunch of file systems mounted that are all of different different geometries, okay? So we need to solve that problem before we make it any worse, okay? So right now, making them all exactly the same simplifies everything. We lose a little bit of disk. It'll be okay. What does this one do? This one says copy into the target disk in this format. Everything here, which represents all the files that are in the progs variable, which we already talked about to death, which are all the COM files named after the ASM files. And as I mentioned months ago, this says put them all in the directory so that user number 0 can see the files. Okay? All right, so we're getting fancy with all these substitutions. Without them, what happens is you have to write out a large number of, you have to name every file manually in here. Giant pain in the butt. Oh, then don't use make. It's much easier to use a script. Good luck with that. Then you'll have to write them all out one by one in a script. Okay? This is the power of make. Go out and figure it out. Okay? But we have to be careful how we write our code and how we use this tool, because it can get very tricky and very confusing very quickly with all this substitution going on. But that's what it's doing. So as it is right now, so far, what we have is the ability to burn a disk. We have the ability to recognize all the source code and figure out what all the names of the executable programs should be. We know what directories all the source code and the COM files are located in after the assembling is done. That's all this, okay? Configure yourself. Burn the card. If the thing exists, go ahead and let me see what all the files are inside of it. And then we get down here. Okay. How then do we compile the actual files? I left these in here commented out so we can see the progression of how I ended up with this rule here, which is the one rule that does them all. Here's the naive way. I can list each individual COM file one at a time. And in that recipe, I can say, in order to create this test1.com, go into the program's example subdirectory and execute make all down there, which is what we've been doing all along, right? In the examples and in the whatever other, I didn't put them all in here because there'd be like 50 of these things, right? Because there's a whole bunch, like the TMS 9118s, there's a dozen example apps in there. And I would have to put a separate rule for every stinking one if I use this technique. Pain in the butt. Here's one, here's another one, and it would go on and on and on forever. What could help a little bit is this right here. I would still need to have a separate rule for every single file, but rather than hard coding this thing here to match that there, I can say what's the directory name of this target, which would be everything up to that slash right there. So at least every time I copied it, I wouldn't have to go in and edit the darn subdirectory name, right? Or we can look at what we've been doing for over a year in the make files, where we actually build the assembler, build the COM files from the ASM source codes. Look what I got going on here. This is the same prefix that we've been seeing for a long time. How do I make an ASM file into a COM file? Well, let's look in the example directory and see what we saw long ago. Quick review. That was this big nasty thing. You may recall. This is how I run the assembler. And I went over great length and talked about what all these little arguments and commands do and why they're there and how I use them. But they're all keyed off of this right here. How do I take an ASM file and turn it into a COM file? I run this command. This command says go get stuff out of the Git environment and create these variables with these string values so that when my program runs, if I want to, it can print out the version and the date it was compiled and all that other fun stuff. Talked about that long ago. Go find the playlist and sift through it. You can see the detail and in those lectures. This over here is the actual assembler that runs. The output file is the name of the target that comes from here. And the input is the dollar, less than or something is somewhere. Oh, the input is right there. Okay. So we've seen this all along, even if we forgot how the thing works. It says take anything that ends in ASM and convert it to that same thing, same name, same text. xyz.asm. The xyz is the percent sign. Turn it into xyz.com. That's what this thing means. How do I do that? I run whatever that does, okay? All right, now let's go back up to the top makefile here. And this is the key. Same exact template, same wild cards. Something that ends in ASM, how do I make it into something that ends in COM? And make is smart. I mean, how does it even know to do this, right? Well, what happens is, way up here, remember, big picture here, the default target is this if I don't say anything, okay? Default target is actually all, which is a fake target that exists for no other reason than to say, I depend upon this. Make that. Okay, how do I do that? Well, it says, okay, looking around, okay, I need that. Well, in order to make that, I need to have all these things existing. Well, what's progs? We just spent 20 minutes talking about it. It's all these COM files that are named after all the ASM files. All right, so all these progs are this whole path is the key. It's not just, example.asm and example.com. No, it's progs / example program / test1.asm. The whole path is in there. The whole path is in there here as well, okay? Therefore, when it says I need to have these things around in order to create this by using this down here, it has to first create all the things in this variable. And they all end in COM. So it says, well, is there anything like this around that says how I can create them? And the answer is no. So then it goes on and says, well, I have a way to make a COM out of an ASM. Well, do I have an ASM? Do I have a file that ends in ASM that is exactly the same name before that I can convert into the same thing, .com? Well, actually, I can. Here's a rule right here. This will make it so. How do we make it so? We say make -c means change directory into this subdirectory. And then once there, do a make all. So that leaves us with WTF is that thing. Well, remember, is the name of the thing on the left. And if I say, hey, what's the name of the directory within which this thing is existing? That's exactly where I want to be to do the compilation, to convert the ASM to the COM. Now, in terms of what I've done here, quite often once down there, it's going to create a whole lot of other stuff too, but that's fine. Ultimately, it needs to create all those. So this is 10 tons of overkill, but what it says is I need all these COM files. I don't know how to create them and they're not around. What do? I can create them out of ASM files. Okay, how do I do that? Go in the directory of each one and compile them. When that's all done, I got the COMs. When I got the COMs, I can make this thing, and it does this. All right? Exactly what we want. When we want to clean up the mess, I'm going to delete all the files that have been generated by the makefile. What do? Well, there's one of them. How do I get rid of all the other ones? Well, what I can do is, you could naively just delete all the COM files if you wanted to. As we know we create them, and we know we have a variable up here that names all the COM files. Those are easy. What's not so easy? Well, all the list files and the symbol table files and all the ancillary byproducts that are littering up our entire file system, along with those program targets. Okay? So how do you get rid of those? Well, what you do is you say for each one of the files in this list here, which are all the directories that contain all the COM files. And remember, that was the third rule up here that we didn't really get into too much yet. I want to know all the names of the directories for each one of the programs. That's what's in this variable here. So down here I say, I have to sort them. This is annoying, but what happens is if I have 50 com files all in one directory, that same directory appears many, many times. And it will go in there and keep doing this over and over. Very annoying. If you simply sort this, it will remove duplicates. So this is only once for each of the directories in the giant list. It will, so it says for each one of the directories in this big list, do this operation. Go into this thing here represents the name of this variable over there. Once it'll do this repeatedly once for each of those directories. It'll go in the directory and type make clean, and then it'll be done. Okay? That's what this thing means. So if I clean up, it'll go and do the right thing. It'll make clean in each one of those subprojects. Done. Okay? And if I type make world, it'll do a clean and an all, which is what it does everywhere else. I'm going to leave this in there for now, just as a reference. How we evolve these more powerful abstract rules. But in the end, as you can see, this makefile should be useful for anybody as long as you put your programs you want to create underneath progs / my project. And you just create a bunch of ASM files down there and a makefile that's suitable for that project and so on. This one will just go in there and make it all happen. If I type make, it doesn't even take a half a second. And you watch what happened. What did it do? It's going to go into each directory and even prints out, hey, I'm going to go into TMS 9918. And when I'm in there, I'm going to do what? I'm going to make, there's the make -c. There's the actual command it did. Go into the directory name that is contains this would be com file and do a make all in there. Okay, fine. So I'm now into this directory. And what does it do when it's in there? We've seen this. We hope to get back to it as soon as possible, too. And it's going to go in there and compile or assemble all those test programs. When it's done, it says, okay, I'm done with this one. I'm leaving now. What else does it need to do? Well, it needs to go and do all the example programs. Why? Because that's one of the many directories that has the ASM files in it that need to be converted to COM files. So now it's going to go into there and type make all. Then what? It's going to go into the TTY directory because it's there and just compile whatever's there, okay? And the last one it's going to do is the NHACP directory. Why? Because it's there. Just type a make all in each one of these things. Walk that whole tree. Do them all. When they're all done, there it is. Delete the old disk image, create a new empty one, and then copy all those COM files that we just created from all those dependencies, all those transitive rules, put it all in the disk image file. And now we've got the disk image sitting here. Right there. I like it better when it lists vertically for whatever reason. If I take make burn, the SD card's still plugged into my USB adapter. And it's been a while since I've done a sudo command, so it wants me to type my password back in again. And we just copied everything out, and you can see the command right in here with all the substitution in the slot number and everything else. So you can see it did SDC1 instead of A because I'm not on my Pi, and I wanted to go into slot 1. I did not override the default, so it's 1 times 16K. All is well. And as usual, I can take the SD card out of the connector, out of my programmer, my USB adapter, I should say, plug it in the retro and hit reset. And we're online here. Okay, so what do we got? I type dir, drive A. What's in here? Well, the only things in there are the stuff that came out of the original CPM build repo, right? Which is the one over here. The one that we went over first, right? The stuff that came out of this file system in here, which is just going to be the build of the CPM files and no extra stuff. And of course, I'm in the wrong freaking branch because every time you click up here in GitHub, it warps you back into the head branch, which I find very confusing, which is why I hardly ever use the web environment, by the way, to do any real work. I only use this to share and to demonstrate what's going on. They present the README files nice and stuff like that, so that we all have a common basis, because you may use different tools on the command line. This one at least is something that we all have to suffer through equally because it's there, okay? Anyway, so I checked out the correct branch, and in the main repo, and underneath the file system directory, you can see that the progs subdirectory has gone. All right. And when I compile in there, I only get the CPM files. And like I said, I left the adventure in there just for fun. And you can see that there's SID and ZSID. Those utilities are in there as well. I believe the assemblers that go along with this are also free and able to be redistributed. I'll have to go get those files and verify that is the case. And I can add them to the system repo and start filling up the A drive with official digital research applications that they have shared with us, okay? So that's what's on drive A. If we go over to drive B now, this is where slot 1 was mapped into. And the reason slot 1 is mapped into this thing right now is because as you may remember, we go over here, you know, to keep all this right in your head. Slot 1 is so defined in this config file here. This defines where slot 1 comes off. Where does the data come off of the SD card for slot 1? It starts at hex 4800. Absolute address of the SD card block number of the first block that represents disk B. And why did that end up over here? And how did it get there? Well, that's where the DD command was 1 times 16K. Well, that correlates to this value here, because 4,000 in hex is 16K. And the partition within which that 16K offset applies starts at 800. Keep all this in your head at once. I'm sorry. Eventually we'll get to the point where we can automatically configure to the partition relative basis, but that'll require us to update the boot ROM to hand over to the running operating system the partition offset value of 800, which we did not yet do. I probably should have done that on day one, but I didn't. Sorry. It's hard-coded in here. Okay, so what do we got? Drive B filled up with all the stuff from the example file system. Among other things, the example programs in here called test 1, test 2, test 3, all of the TMS 9118 example programs, the teletype program, and this thing is my little test program that I'm messing around with that I hope will be NHACP someday. This is my early test routines and stuff that I'm writing so that I can run them on the command line, like I said earlier. I'm way over time this week. I'm going to have to talk about this and its use of that $top variable. It's the only one of the applications that does that. I'll have to talk about that some other time. Spoiler alert, it has to do with the fact that this program actually links in the libraries that are inside the BIOS so that it can test them, okay? And therefore, it needs to know where the BIOS is. It's as simple as that, okay? But we'll look at how the makefile that generated this thing works at another time. Meanwhile, you can run, these programs. You can run stuff off of disk A. You can, we can go over to drive M if we want to, and we'll have nothing there because, as you remember, I erased all of them. You can go all the way up to drive P if you want to. There is no drive Q. Okay. CPM doesn't do a very good job at preventing you from going over there. But whatever, you can go to F and J. I'm doing this on purpose because every time you go to a disk, you'll notice it takes a little while. Now, if I go back to like A, it goes quick, right? F, I was already there. What happens if I go G? Well, this is the first time I'm going to G since the last time I warm booted. It takes a little while. What's it doing? Remember early on, what does it do when it warm boots? Whenever you access a disk the first time, what it's doing is it has to read the entire directory in order to figure out the ALV. Why does it take long? It's because it's calculating all the bits in that ALV to remember what is in use and what's not on the drive. Now, once you've done this, once you've logged in a disk, as CPM calls it, you can run the stat command And for every disk that you have used, it will tell you something about it, like its geometry. All these are the same. Why? Because we did that on purpose. Keep the driver simple. And it'll tell you all the geometry of each one of the drives that you have used. If I do a warm boot with a Control-C and I do another stat DSK, you will see it has forgotten about all those other disks. All right, because you've never logged them in since the last boot or warm boot. Okay, and just FYI. If you do a stat star dot star, what am I on, drive B? It doesn't have, I have to tell it where to find it. Oh, the burden of having all these drives now. And if you want to run a command that's on a different disk, you have to tell it where it's at, that's all. So you run star dot star, it tells you how big each one of the files are, how much disk space is remaining, and go over to A, stat star dot star from here. And now we'll see what's going on drive A. Got 7792, 77. Well, that's a coincidence. Same amount of disk. What are the odds of that happening? Probably not too good. But I'm going to go with it. It actually, the odds increase when you have a larger block size because there's less variation in how big the files all are. Okay? I'm a little surprised, though. Bytes remaining, 7792 on B. It makes me wonder. This is very confusing because these have got some really big files in here. They're not the same. 7992K versus 7792K. Oh, it's getting late. My eyes are tired. I've had it. Stick a fork in him. He's done. Okay, like I said, it's not likely, and it turns out it isn't the same. Anyway, a little bit of looking around. We now have as many disks mounted as you can possibly tolerate having in your system. And I give you an example on how to create your own file system image if you really want to. Where am I? I'm in the, this is in the BIOS there. Go back over to the individual file system. I encourage you to look around a little bit in here. In this progress subdirectory, if I just say ls star, we can see all the files and all the subdirectories. We've been seeing these on and off again in the channel while we're over in the BIOS build, repo. Now they're on their own. You can take this, copy the files, make files and everything else, hack these up and make your own projects and programs and stuff like that. You can make your own GitHub repo. You let us know about it. I can link to it or post a link to it in here so everybody can share, you can share your work with everybody else. Get riches and fame and all that fun stuff. I'll add some more bullets in here. I think that'd be so cool. To that end, what's going on right now? Well, I know somebody in New Zealand who is working on some games, and he's working in C. So those of you that like writing C programs, maybe what we can do is get a repo full of his stuff going and running on the VDP. I mean, this is where I wanted to go. I want to get this stuff factored out so we can contribute. And I also want to get network-mounted disks so I don't have to keep moving SD cards around. We're getting there. Baby steps. Thanks for watching. Let me know what you think. If I made mistakes, there's better ways to do this. I'm open to any recommendations. Thank you for watching. I'll see you next time.